quickly dive into this presentation. So today I'm going to talk about generative design and automation. I'm a bit curious, apart from our technical, who has done this? Because this has been there in the industry, not in Sri Lanka, in other countries for last, I would say 15 to 20 years, but as a country, as an industry, but we are quite late for the party. That's why I want to talk about this. First, I'm going to talk about generative design, then automation. After that, use of generative design and automation to optimize structure. Finally, the future of structural engineering. This is quite important. As structural engineers, I would say we use the conventional methods. Once we get this architectural drawing, we try to develop two structural concepts to optimize the cost. That's what we do, or rather one option. Then we do our structural analysis using ETAP, SAP, or STATCO. Let's say all these finite element modeling software. After that, we do our analysis. Gravity load, lateral load, when it comes to wind, seismic. So wind sometimes yes we do wind tunnel testing. Then seismic we do lateral equal lateral force, response spectra, time history, pushover, or we say we don't do anything, let's incorporate integration detail. That's how we do. After that, we develop designs, then produce the for construction. That is what we have been doing all these years. But for tomorrow, for the future, that's not going to be enough. One thing, because we have few more KPIs, especially embodied carbon, not just the embodied carbon, could be operational carbon, then accuracy of the design, material, life cycle cost. And recently, I have found out the manpower is an issue now, because most of the contractors are bringing down engineering labors from India. It means now, as a structural designer, we'll have to think about that. Yes, we know we need that knowledge tomorrow, yesterday's knowledge, but now AI is there. These modules are learning at a rapid pace and evolving at a rapid pace. Because of that, we need to think about the future purchases. Right. What is generative design in structure? So, a computational process where the engineers set goals, constraints, and KPIs, and the system automatically generates and analyzes multiple structural options to identify the optimal solution. Here, we create the design space, and this software will generate thousands of options for us to find the optimized one. Three drivers: increasing complexity of building, and we have now different KPIs. Then short delivery timeline. When we work, I would say international projects, now there's a competition, especially from Indian engineers, Philippines and Vietnam. So we need to deliver the project with short period time. Then pressure to eliminate over design, because anyone come and challenge you and pressure you, say this one. Because of that, we need to get ready. Again, we need that pressure to justify every decision along the way. One another thing, we need to go for performance-based engineering, because now we have been using code-based design. The code that has developed 30 years ago, is that applicable now? That's a big question. Because of that, we need to move into performance-based engineering, client expect optimization, not just design, and sustainable expectation. Where we use generative design and structural engineering. As architect has done most of the time. I have seen architect have done some work on this. So as structural engineers, we need to think about the structural layout, member sizing, structural system, this carbon, then let's say aerodynamic form. Just think of a building 500-meter high-rise building. So I can say, okay, because wind going to be quite critical. I can say I'm going to twist the wind. And other one can say, okay, I'm going to make a hole. The third one can say, okay, let's set back certain part. But how can we assess that? So each and every solution, we need to assess each and every option. Then when it comes to generative design too, we have three. Rhino, the grasshopper is interface or Revit Dynamo. There we have different plugins to do this optimization, right? Because others plugin like Canva, because it's not like ETAB, but quite very basic, but we can do it. Now let's move to automation. Generative design is just a theory without automation. Automation means allowing computer to do repetitive role-based engineering tasks so engineers can focus on judgment, creativity, and decision making. Think of developing 100 ETAP model for 100 architectural layout. It's difficult. We can't do it. So automation means delivering something with speed, with accuracy, especially without human errors. So key drivers are very much same to the previous one. Then when we use automation, modeling automation, analysis automation, design code, checking automation, documentation automation. Think when we change a beam depth in our ETAP model, getting our calculation report updated, so that need to be there. Having said that, I would like to talk about structural optimization with using automation and generative design. So I will quickly go to a process, but this process is universal. Right? I'm going to explain because it is quite easy for me to explain. Once architects develop the architectural layout, we'll have to develop the parametric model, either Grasshopper or Rhino or yeah, I think this 2, 3, 4, 5. This thing need to be done as a team. I know architect has done. I think you should ask us to join them, right? Because there are certain variables: grid spacing, column layout, core size, beam depth, outrigger position, and there can be when it comes to architect, there can be another variable, right? Light to the building or shadow of the building can be. After the building, into the building. So also these are variables. So we can develop the parametric model, and we can use these variables and constraint. Finally, we can get this algorithm. So there are plugins. So we can connect this plugin to this generative model. So after that, we can get multiple options with score to different KPIs. With that, we can get the best option. But here also we need, as a team, developer, architect, as engineers need to be there, and we need to find the best option. So thereafter, the process is quite conventional. So we can export it to ETAP, so we can develop the model again, then remember designs, and finally detail. So I will show you a quick demo. It's just it's a quick demo, also shows this creation of a parametric model, right? Because this is the Grasshopper interface, that is Rhino. So this is like a game. So we can really design, generate that thing, and these are the numbers that are available. Then we can connect this plugin to optimize the structure. Actually, as a country, we have not done that optimization part, but this is the easy part. But at least we have to start doing this, and then only we have to optimize. Because with AI, there could be thousands of plugins. I would say next year, so we have to be ready. Now, future role of structural engineers. I think we know if we form correctly, we can get good results. Right? That's obvious, right? Even using ChatGPT, we can design. because then our prompt should be correct. Or else we need to have a proper ChatGPT model. So I can feed my calculation and I can feed the code. I can feed Mr. Shiroma's calculation report and we can ask them to, based on this, develop my calculation. See? See? Because that is the future, right? From calculation to judgment. AI handles routine, engineers need decision making. Next, from linear to iterative. So, to generative design, I talked about generative design. So, we have to use that. From manual to intelligent optimization. I think we should not say that we optimize the structure by calculating the quantity. That's what we do, what we did all the time. It's not really optimization, right? It's something else, but now we have to switch to this. Then from specialist to hybrid professional. Once we work in the industry, we can become professional. So we can become a high-rise expert, we can become a wind, seismic, force tension expert, but we need to have this computational knowledge. Again, sustainable, automation-ready engineering. That is the future. Finally, from isolated to integrated. Architects do their design, then they forward us to our design, then we forward it to MEP engineer, then QS, that is what we have been doing all the time. What does not going to learn? Everybody should be in the cloud, right? So it should be BIM. So I would say from next year onward, we should, as officers, we should think of that. So I'm going to show this. So 2 years back, I was there. I was working in Manhattan. I saw this building, this 270 Park Avenue building, JP Morgan Tower. I waited like good 4 to 5 minutes. Went around the building. I was quite surprised about the design, and because there are so many metro lines underneath, that's why that bottom part came out. So then I was intrigued, but I was sad about myself and the industry, because here what we do is just a tiny fraction of what they do. So then I researched about this and came to know about all this automation and generative design. That's where I started. Then the big question, will AI replace the structural engineers? AI will not replace structural engineers, but structural engineers who embrace AI, generative design and automation will definitely replace those who don't. Within 3 years' time, mark my word. So, what this means for us, starting today, invest in parametric modeling, integrate performance-based engineering, shift from drawing-driven to model-driven practice. Your boss might say, okay, you should not do modeling, stick to basics. No, that's not going to happen. Finally, treat AI as a junior engineer who works 24/7. So it's the future. To conclude my presentation, I would like to say this. Let's rethink, redesign, and reinvent.